It's 6:30 on a beautiful sunny Sunday morning. The morning doves are cooing outside. I've got my coffee and my CNC mill. Let's make some chips. Welcome back to Cloud 42. I'm James. Today we are going to continue work on the spindle mount for the new high-speed ATC spindle for my Grizzly G0704 mill. Last time we prepped all of the blanks and machined all of the stock to size. This time we're going to get into the CNC machining of the features on the parts. And as usual, the size of the mill is going to present some challenges. Let's get started. Okay, we're going to start with the biggest piece, which is the back plate, and this part has already been milled to size overall, and it's 1 1/8 inches thick. And we need to cut a pocket and put some screw holes in it, and then put some countersunk screw holes to hold the rest of the head together, the head assembly. And the problem with this part is twofold. One is I don't have enough Y travel on the mill to just put this in the vise and come all the way across and be able to get the holes on the other side. The other issue is that when I turn it this direction to do the features in just one end, it's a little over 6 inches and my vise only will hold a 6-inch part with all the jaws in. So what I've done is I have removed the back hard jaw from the vise, just took out the screws and took the hard jaw out, and we're going to clamp directly on this softer steel sub jaw. Now, if I were clamping steel in here, I would be worried about it and I would probably put something else in here, but since we're just clamping aluminum, it's not going to be a problem. I'm not really worried about damage to this back jaw. So we need to drill all the way through this part, so I'm going to start with some 1/2-inch parallels and put the part in. Now I also have an end stop set up here, and that's because we're going to flip this around, and I would like to only locate on this part once and not have to repeat that operation. So I'll tap that against the end stop and clamp it down, give it a little bit of grip. There's not going to be a lot of machining forces on this. And then seat it with a dead blow, while trying not to strike the Heimer that I already have in the spindle. Okay, that looks good. According to the setup sheet, our 0 is going to be on the end of the part, top center. So the 0 we need to find is right here on this edge. So I will come down with the Heimer, find this edge, then I'll find the two sides and use the half function on the DRO to find the center, and then we'll touch off on Z. Let's get the Heimer out without breaking the tip. Again, dropping the wrench is optional. Okay, the first tool is tool 2, which is a spot drill. 1/4 inch, 120-degree spot drill. And this is just going to be to spot the holes where we're going to drill through, and in the center where we're going to drill for relief to start the milling. Make sure we are in high gear, 2200 RPM. Okay, next up is 101, which is a through drill, and that is a letter L. I've got this loaded up in a 5/16 inch collet, which has a clamping range that'll clamp down onto that. And this is what I was missing last time, why we couldn't continue. But we've got it now, so should be able to do our drilling. This drill is going to break through, so I am going to go ahead and torque it by hand. Boy, there's just nothing quite like a brand new drill in aluminum. Making sure we got those broken all the way through, and sure enough, we do. Okay, the next tool is a 1/4 inch Alupower aluminum specific 3-flute end mill. So this is a long end mill, and the reason I'm going with the long end mill is because the pocket in the center is actually deeper than the cutting length on the regular length mill. So we'll run the long mill. It means we have to hold back on the feeds and speeds a little bit just because of the additional flexibility, even though it's carbide, but it should be fine, and we should get a good finish in there. So we've got the pocket, we've got the 3 holes bored, and the hole down the bottom of the pocket bored to size. Now I do want to check the dimension on this pocket, because if it's out a little bit, it'll be really easy to fix right now, and fixing it later will be much more expensive. See, the target dimension on that is 1.972, and I'm just going to use an inside micrometer here, and let's see what we've got. Trying to feel it, make sure I'm getting the max size here. Getting 1.958. And it says I want 1.972. Let me double check that. Do an idiot check. $1,958.5. So we are at 1.958. So let me go rerun that contour with another 5 thou on the side, and that should bring us to size. Okay, 1.971, and I'm going to guess 7/10. I'm going to call that good. That's within 3/10 of our desired diameter there. I'll check the rest of these holes and make sure they're to size as well. And we're about 460. We're within 2 thou on these long bores. This is fine. These are just nice loose clearance holes for the T-bolts to hold this on. So let's go ahead and run a chamfer on it and be ready for the next operation. And if you're wondering, the reason that I'm measuring these so precisely is that I do have some other features to mill, and also future projects I'm going to want to be able to hit diameters very, very precisely if it's needed for that project, needed for that part. And so the more I can call my shots, design what I want, measure what I get, and adjust, the more I learn, and the better that prepares me to be able to do a better job on future parts. Now, the other thing that we need on this part are some counterboard screw holes that go through the back of the part, but those are actually shifted down further on the part in this direction, and I don't have enough Y travel to reach all the way out here, so in order to do those, I'm going to have to flip the part around. And this is precisely the reason why I did the setup the way I did with this end stop, so that I can flip it around without having to reset things. And I've got chips everywhere, so allow me to clean this up a little bit. Okay, so turning it 180 degrees, drop it in here, bring it over tight against this stop so I won't have to re-zero anything, and snug it down. Couple shots with the dead blow just to make sure the parallels are tight. And we're ready for the next stop. 120 degree spot drill. And for this operation, I've actually turned off the soft limits on my mill because I'm working right out close to the maximum of what I can reach. Okay, next tool is an L drill. Held in a collet. Okay, and the next tool to bore out the holes is going to be back to the long 1/4 inch end mill. Okay, these don't have to be precise, they're just clearance holes and countersinks for 5/16, 18 screws, and that looks pretty good. Make sure it's deep enough. It's definitely deep enough. Yep. And the last operation in this setup is going to be a chamfer. We gotta love a nice shiny part fresh out of the CNC. Okay, if you were holding your breath because I was milling without a vice jaw, you can start breathing again. I've got the vice jaw reinstalled and I've re-enabled the soft limits on the mill because this next part doesn't require as much reach. So we are going to mill the screw pockets in the top of the side plates. So I need to get this positioned in the vise, and since this is a thinner part, I'm going to put it up on 3/4 inch parallels. So as your 3/4 inch, 4-inch parallels for the 4-inch vise. These are really handy. I ran with 6-inch parallels for a while, but I found that I always had them. They were sticking out, they were getting in the way, they were snagging on things, or in the way of my setups. I'd have to hang all of the excess off of one side if I was side milling. So the 4-inch parallels are a big improvement. Okay, and I'm going to bring the end stop in here as well because I know I've got multiple parts to do. Now, instead of pushing the end stop up against the part after it's clamped and then hoping the next one will repeat, I'm going to actually loosen this one up, tap it against the stop so that when I put the other piece in, the amount of pressure against the stop will be identical. Got that in. And the parallels are tight. Now, I already have the Y distance. The Y0 hasn't moved, so all I need to find is the X center and the Z. But for that, we will need to bring back the Heimer. And if you didn't catch it in my previous videos, I do not use the air ratchet with the Heimer, because the Heimer has a little structure in the top here where it floats on the spindle and it's held in with 4 set screws that operate like a 4-jaw chuck to center the tip. And I find that when I hammer it when I hammer my delicate instrument with an air wrench, it turns out it knocks it out of alignment. Who knew? I will torque this down, not because there'll be a lot of force on it, but just because I want to make sure it's pulled completely centered. Let me just go ahead and check my Y0 while I'm here. Oh no, the Y0 has to change. I almost forgot. If you were screaming at me, good job. Because I put the vice jaw back in, the Y0 has to move. Or I would actually try to mill the jaw. That would have been fun too, but okay, try not to drop the Heimer again. And that's beautiful. Just do an idiot check with a screw head to make sure it goes down below flush. And it does, and we have clearance. Oh yeah, easily. Now, it's not sitting down below flush because this screw is long enough it's striking the vise underneath, but looking at it this way, I can see that I definitely have the screw head below the surface, which is all I need. Okay, the next setup here is going to be to cut the side notch in this side part. There's a cutout that makes room to get a wrench around the bolts in the back plate. And there are 2 mirror images of this part. They both have these holes in the top. One has this notch on one side, the other has the notch on the other side. So I'm going to go ahead and take advantage of the fact that I already have the part in the vise, and I'm going to go ahead and run the next program and cut this notch. Then I'll put the next part in, cut the 2 holes in the top, and then I'll have to flip it so that the notch will go on the other side, so it'll be a mirror image. So let me get go back to tool 15, the 1/4-inch end mill, and let's cut a notch in the side of this. And let me double check and make sure it really is calling for tool 15. Yes. Fortunately, this part is thin enough that I can use the short end mill and still get all the way through, or the standard length mill. And that's beautiful. The surface finish is just gorgeous in there, just like a mirror. But the actual dimensions of this don't matter, so I'm not going to bother trying to walk it in or anything. I'm perfectly happy with that. Let me grab the other part, and as long as we've got this tool in and this setup, I might as well drop the other part in and go ahead and cut the notch before I flip it and do the screw holes. Now, if this part were supposed to be exactly the same as this one, then I would just go ahead and run the program to put these holes in it. But this part is actually supposed to be the mirror image, so I need to flip it over and then put the holes in. So let me flip this part over, load the other program, and we should be good to go again. Okay. And that is the part. Aside from some drilled and tapped holes in it, this thing should be complete. Let me wipe this down, do a little deburring, and I will meet you over at the bench. Okay, I've got the parts we made today here over on the bench. I've been doing a little bit of deburring. I'm just using this little Noga rotary tool and cleaning up the burrs on the back sides of all these holes. This tool just makes quick work of these things and leaves a nice, pretty little chamfer. I've been very, very pleased with this. There's a link down in the video description to this if you're interested. But it just puts a nice, beautiful, I don't know if you can see those, nice, clean little chamfers, takes all the sharpness away on the back edges. If I have it in the CNC, I'll go ahead and CNC machine a nice chamfer on it. But if I don't have access to that, this tool is a beautiful way to do it. And then for inside these countersinks, there's another type of a tool that can reach in from the back. And if you can see the tip of that in there, and it just goes around and cleans those up. So I've gone over all these parts, they're nice and clean, and like I said, I just love a beautiful CNC milled aluminum part. So the way this is going to work, this goes onto the Z-plate of the mill, and then screws go through these holes to bolt on the front parts. So this will be this direction, and the 3 sets of bolts or 4 sets of bolts that hold it down to the mill are here, and then these plates go on the sides. And again, these have countersunk holes so that this plate will attach on the top, and bolts will go through these holes into that side plate and up through these holes to hold into the top plate, and then up through these holes to hold on the side plates like this. And then this cutout here is there so that it's easier to get at the head of this bolt, either from the outside or from up this direction. It just removes the interference between the bolt head there. And then this part goes on the other side. And that is the spindle mount. And then the spindle mounts to this front face with holes drilled into here. So all I have left to do on this is drill and tap holes into the assembly. And I'm not going to have any more time to work on that today. Oh, and I also need to cut some triangles off of the bottom here. That was a part of the design, or maybe even put in a curved surface here. I'll take a look and see if I can find a good way to hold it to CNC machine a curved surface on the bottom. That would also be cool. As far as drilling the holes, I'm not super confident that even with spotting, the holes are going to be exactly where they need to go, and the clearance around in the through hole on the spindle is very, very small, so there's going to be a lot of precision required. I'm going to think about that a little bit, and we will pick up on this next time. I don't have any more time to work on it today, and the video tanks on my devices are all full, so I think that's going to be it for today. If you are enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.